In Part 3 of Lecture 6, we will look at constructing the initial state of an LR0 state machine. It's probably a very good idea to take a moment and be sure that we are comfortable with a few terms that we will see a lot of, starting with one that we have seen before, a sentential form. A sentential form is a partially formed sentence or program. What distinguishes it from a sentence is that while a sentence contains only terminals, a sentential form will contain a mixture of terminals and non-terminals. We are usually talking about right sentential forms because they are on the right-hand side of a production. In a context-free grammar, we will never see a terminal on the left-hand side of the production. Right sentential forms are derived from the rightmost derivation, and formally, if we say S ultimately derives beta, that means that beta is a right sentential form. There are a few definitions which we need to know before we can go ahead and start building the state machine. One term is right sentential form. Right sentential form is a partially formed sentence or program. It can contain the variables on the right-hand side of a production or phrases derived from it. Right sentential forms are derived from the rightmost derivation. Formally, if S ultimately derives beta, then beta is a right sentential form. In performing a reduce operation, we must decide which variables in a right sentential form will be popped and replaced on the stack by the non-terminal on the production's left-hand side. These variables collectively are called the handle. If A derives beta, then beta will be the handle for the production. An item is a production with a dot added to it, indicating how much of the production has already been matched up so far. So for example, E derives dot E plus T. We haven't matched up anything on the right-hand side yet. On the other hand, if I have E derives E plus dot T, we have matched the E, and we have also matched the plus. Given our experience looking at regular expressions and finite automata, this is what we might expect the state machine to look like. But the truth of the matter is it isn't. This does not account for many of the things that we'll deal with, and we can talk about these very shortly. We already know that processing context-free grammars requires a push-down automaton. As we prepare to match tokens in the item S derives .E dollar, we really have no way of knowing what the tokens are that in this instance will represent E. We have to consider there may be many possibilities, and we can see this in the items that follow. E derives .E plus T, and E derives .T. We will add these initial items to the state machine in this state, so that we have some idea about how we will go about recognizing when we have everything that's going to be part of our expression. Since matching a collection of tokens to E may mean matching them to T as well, we need to know what to look for in that case as well. And we can see that here. T derives dot plus F, T derives dot minus F, and T derives .f. Similarly, since matching a collection of tokens to T may mean matching it to F, we must know what to look for here as well. F derives .id, F derives .constant. Since we know exactly how to match ID and constant to tokens, because they are terminals, we don't need any additional items. Similarly, in the productions on the previous slide, T derives dot plus F and T derives dot minus F. We don't need to look for additional new items for these because the dot is before a terminal in both cases. State 0 will always begin with the special start symbol deriving the regular start symbol followed by the end of file marker. The dot is before the E because we haven't traversed past the E as of yet. Having the dot immediately before a non-terminal, in this case expression, I now need initial items for expression. E derives dot E plus T and E derives dot T. I don't need any additional items based on E derives dot E plus T. I already have them. However, E derives dot T means I need initial items for T. These will be T derives dot plus F, T derives dot minus F, and T derives dot F. T derives dot plus F, T derives dot minus F does not require any additional items because the dot is immediately before a token terminal, and I already know what I need to get past that. But F is a different story, and for that reason, I'm going to have F derives dot identifier and F derives dot constant. I have initial items for every instance where the dot is immediately before a non-terminal. So at this point, I now have state 0 for the LR0 state machine.